Hello and welcome to the Omnex webinar, Preparing for the AIAG-VDA FMEA Handbook. Today's webinar presentation will be presented by Antony John and Michael Down. Michael Down represented GM at both SAE and AIAG, providing extensive guidance and input on the development of global automotive standards, reference documents including quality and core tools, APQP, TPAP, SPC, MSA, and more. He's currently an active working member on SAE J1739 committee updating the FEMA standard. Antony John is the Vice President of Omnex Systems. He has 19 years of experience transforming technology businesses across global market and different customer industry segments. All right, you can take it away, Mike and Antony.
This is Mike Down. I'd like to welcome all those that are online that are listening to this webinar. Get into talking about the upcoming AIAG-VDA FMEA Handbook that's being released. The release date currently looks like it will be sometime in May or June. Again, we're not really sure, but it's going to be out this year, and is getting support from Ford and GM and Chrysler and some of the other automotive companies. So purpose of this webinar is to kind of evaluate the changes from the 4th edition, and also some things you can do to start preparing if you have a customer that's going to require you to follow the handbook. And just kind of go through some of the slides. This is just talking about Omnex, and I'm going to just move ahead. And this just has a picture of me and Antony, and get up to the agenda. So one thing that we're going to be reviewing is that the 7-step process that's in the handbook. In a DFMEA, so far we've been doing boundary diagrams. There's structure diagrams that are talked about in the handbook, and we'll look at that. We'll look at function net, which is in the handbook, versus functional requirement, failure net versus failure mode cause, the risk analysis optimization, which is replacing RPN. So RPN and action recommended actions is going to be changed. Risk communication and the old form and new form, and then we'll be talking a little bit about the Omnex software solution. One thing I'd like to point out right at the beginning is one of the big changes is that the VDA AIAG Handbook, FMEA Handbook, will not be a core tool document. So big change is that the core tools, the blue books, were owned by the strategy board or by GM, Ford, Chrysler. Now with the VDA AIAG Handbook, that's going to be owned by VDA and AIAG. So that's one of the changes that's going to be going forward. So not really sure how that's going to impact APQP and the other core tool manuals, but progressively in the future we may see all of these documents transform into the AIAG VDA Handbook family. So one of the things that you'll see when you get the handbook is it's set up as a 7-step process. It starts out with scope and definition, and this would have been considered pre-work in the 4th edition. Then we'll look at structural analysis. This would have been the boundary diagrams in the 4th edition. Functional analysis now will be replacing the function requirement columns. Failure analysis will kind of replace the causal side, and then risk analysis will replace RPN. The risk analysis and optimization area will be replacing what eventually was the RPN analysis, and then they added a 7th step about 6 months ago, which is the result documentation and how that information gets utilized and how you keep the FMEA updated over time. So this is kind of an eye chart, but basically you'll see that the step 1, 2, and 3 is the system analysis, and then 4, 5, and 6 is the failure analysis and mitigation of the risk, and then step 7 is our risk communication. So they've kind of laid out which each of these areas are going to be. Now, this is another change that's going to happen with this new AIAG-VDA Handbook, is that the 4th edition, we basically said that the format of the form was at the discretion of the company, and they, as long as it had the basic information, they'd be okay and acceptable. With this new AIAG-VDA FMEA Handbook form, you just have one type of form, a standard form. There'll be a standard form for both the DFMEA and the PFMEA, so that's a big change. So the first step is a scoping step, and this would be considered similar to the pre-work that was done in the 4th edition, in the fact you're establishing your team, the scope of the analysis, when it's going to be due, why you're working on it, what tools are going to be conducted in the analysis, and what the purpose is. So that's pretty standard. There's some new information that would be needed, but not anything that's really substantial. Now, if we look at the form, you'll notice already that you have it's kind of broken up color code wise, but you have the first section that's your what's the scope. So we actually now have columns in the form that would capture the scope, and that would come off of what would be considered your structure diagram. We'll talk about that a little bit later. And then you do what are the functions and requirements. Now the functions now, you'll hear terminology like function net or function sequence or function, what it basically is talking about here is that you're trying to capture what the overall system function is, what the subsystem function is, and what the component function is, and how they're tied together. So this sequencing is going to be captured so that now if I have a component, I have to have some understanding of how that component's used in the subsystem, and then how that functioning subsystem that my component's involved with, how does that affect the overall system. So if we're talking about a car, the vehicle would be the overall system, and then a subsystem could be a brake system, and I might have the calipers. So I'd have to understand how my calipers fit into the brake system, and then how the brake system fits into the overall vehicle, and how a failure in the caliper would affect that. And that gets us into the failure analysis. And basically, the failure analysis will follow the function analysis in relation to how does failures sequentially fail up into the system level. And you'll notice one of the changes is that the effects one comes before the failure mode. And you'll see this where cause, failure mode, and effect are set up, and I'll show you how this works in the structure diagram. But that's kind of a change from what we've been working with before with the 4th edition. And so we're looking at what can go wrong, what are the causes, and how does this impact the customer. So kind of getting back to connecting this linkage between failure to my component, failure to the subsystem, how does that affect the customer, which would be using the system level effect. And so then you'd have to consider, well, now how do we prevent this, and how can it be detected? So all that's kind of interwound in the analysis. And then we do the risk analysis, and this is going to be, I'll go in a little bit more detail later, but basically what they did is took, if you've ever seen the red, yellow, and green type of failure analysis that scaled the severity to occurrence and showed a red zone and an orange zone and a red zone, so red, orange, and green. This is kind of using the same logic for establishing what's my risk, and then eventually getting down to how do I optimize that risk. So we're doing a scoping, and then a structure analysis is 2, and then a function analysis, which gets us into our functional net, and then we're getting a failure analysis, which gets to a failure net, and then eventually we do a risk analysis, and then using the scaling that we've established, we'll come up with optimization, and that's another thing I'll throw in. The scales have been tweaked a little bit, and will be a little bit different than the severity, occurrence, and detection scales that we've had before. So if we look at the big difference between the old form and the new form, the old form, in some of the older forms, we had item function. In some of the newer forms, it was broken out to item function requirement. Now what you're going to get into is more of a structure analysis that then will lead into a function. So instead of just having an item, you're really going to be working on what's called a structure analysis. And so we still recommend the use of a boundary diagram. When I was working at GM, I did a lot of work with this type of a system, and we still needed to do boundary diagrams, because when we go to the structure diagram and explain the structure diagram, you lose track of what the design interfaces are. And so we still would recommend from Omnex that we still would use boundary diagrams, even though it's not a requirement in the VDA AIAG FMEA Handbook. Because what they now use is what's called a structure diagram. A structure diagram basically starts out with the system level product, which in this case would be a car. Then it would go to the subsystem, which could be, in this case, an airbag, if we look at the graphic at the bottom of the page. And then it gets broken up into components. And so these connections that you see between the components in the system and then the system to the product would be what would be called the function net that we'll be talking about later. But we establish structure. So it basically looks like this. It doesn't tell you physically how they're connected. It's just that this subsystem is made up of multiple components. And that's, so the structure diagram is what you start out with. And in Excel, they've got an Excel spreadsheet that sets up the structure. So it's going from your component to the focus element to the next higher level element. So you'll hear these connections and elements talked about in the structure diagram. So then the function analysis will then follow the structure diagram. So if we look at this example, we have the system is the car, and the functional requirement is a safe transportation. The subsystem is protects the passenger during collision, which then to do that, we need to deploy airbag on demand during collision. And then the component would be the sensor. So if I'm the sensor supplier, we'd be activating the airbag during collision. So to understand my failure effect, I need to understand what this functional net, how that works. So we do this functional analysis based off of the structure diagram. So the first if we had one of the recommended formats of the 4th edition would be item, function, and requirement. That now is going to be 6 columns in the new form. And so the second column, which would have just been function requirement, now is functional analysis. Functional analysis then would follow the structure analysis, and they would call this, that could be called a function net, which would then be the connection of between the component to the product to the subsystem to the system. And so this is kind of a nicer way to look at the diagram. At the top shows you the structure diagram. So for each of the different areas of the structure, you have to come up with what the primary functions are for the component, the subsystem, and the system. So what I see, one of the challenges here is that this becomes a challenge for the OEMs, because they have to provide better definition of how a first-tier supplier's system integrates with the vehicle and how it affects the function. And then if I'm a first-tier supplier, I have to give more definition down to my subsystem and component suppliers, this chaining of the system level to my subsystem to whatever second-tier and third-tier suppliers you have. So there is information that's going to have to be additionally provided in very descriptive form to tell me how at the different level I am in this functional net, how I affect the next level in the system. So then as we go on, we now have the failure analysis. Now, this is commonly known as the failure net. And the failure net is, how does a failure at a component level then affect the subsystem? And then if that subsystem has a failure, how does that affect the overall system? So again, if we go to the diagram that I provided earlier, this kind of shows better what needs to be done. First, what you would do is look at what failures you don't want to have at the system level, and then what type of failures could happen at the subsystem, and then what failures you could have at the component level. And then somehow you have to chain how a failure in the component may result in one of those failures at the subsystem level. And then the subsystem level would have to understand how things would fail at the system level. And so they call that a failure net, which is more realistic of how failures work, is that when I have a fail at the subsystem level, or at the system level, let's say I had a failure in my brake system, I would have to do a root cause analysis and rifle down through the system and eventually find what component actually caused the failure. So this makes a little bit more sense from a logic point of view, but again, requires more information that's going to be provided. It means that the OEMs or first level customer is going to have to supply the first tier suppliers detailed information on what failures they don't want to see happen. And then the first tier suppliers are going to have to explain to the component suppliers what failures they don't want to see, and that they'll have to chain to the component level. So this becomes more communication information about failure information. But they call this a failure net analysis. So this failure chain becomes the failure effect. So what we used to call the effect from the customer, now this is going to be changed to what's called a failure effect, which will be at the system level, is the consequences of the failure mode. The failure mode will be how something fails. Failure cause will be related, if I'm at the subsystem level, could potentially be caused by the lower level supplier. So there's this failure cause to failure mode to effect, which is the sequencing and this is what's changed from what we had today, because before in the 4th edition manual, you would have what's my failure mode, and if I have a certain failure mode, what would those effects be to my customer? This is kind of going in, these are the kind of effects I don't want to have happen, and what failure modes could cause those, and what causes could cause the failure mode. So again, it's a little bit different sequencing method. So then the area which would be called the risk analysis gets us into the what are the different causes and what's our ranking. So in step 5, the risk analysis, RPN's been eliminated by risk analysis, and there have been updates to the severity, occurrence, and detection table, which we don't have a lot of time to actually go through those, but there's been some tweaking to those documents. But basically what would happen is that you go down to the causal level and you'd look at your preventative actions, which would affect your occurrence ranking. You'd have a detection of those causes, which would be your detection ranking. And then you would have your rating for the severity, which would be the effect to the final customer. So you see this is a little bit different in the fact that you really have to have an understanding of what those final customer vehicle type failures would be and what type of risk ranking they would have. So again, what that's saying is at the OEM level, they would have to give you information to have an understanding that if a certain effect occurred, what would be that severity ranking? Would that be a safety type issue? Would it be a primary, secondary function, or would it be a qualitative issue? And then the way that the failure net works out, then the causal part of it would be what I'm working at the component level. Now there also could be things done at the tier 1 level, but a lot of the focus is on this component subsystem system level failure. So there would also be this preventative action and detection at the failure mode level also. So then a big thing that was discussed and worked on this VDA AIAG handbook was the fact that there was a lot of confusion on once I get this RPN value, do I take action or don't I take action? So you had kind of generic requirements that were set up for RPN and RPN value. In the old 4th edition, we said that setting up some type of a level of RPN to do action wasn't a good method to promote improvements. So what that has done is it's changed in the fact that we've gone from this having an RPN at 1,000 is the highest, because you took your highest severity times your occurrence times your lowest detection, and that's how you got your RPN value. And then in both the J1739 and the 4th edition, we said, well, setting up some type of threshold value isn't a recommended way of improvement, and the reason being is the fact that you can, those are subjective values, especially in the occurrence and detection, that can be adjusted. So there's no value in pushing people for some type of a threshold, because they can easily adjust the numbers to get to whatever threshold level you want. So change is the going to an action priority table. What happens is based on your rankings that you give for severity, occurrence, and detection, you come up with a action priority value. It's not really a value. You're either, once you go through the analysis, you're either at a high, medium, or minimum level. And basically, you would be focusing on doing some action to eliminate any of the high action priority numbers that you'd have. And then the medium would be discretionary, and then the minimum you would skip. And so you get this priority high. The team must either identify an appropriate action to improve in prevention or detection, or justify and document why current controls are adequate. So not a real big change, just a little bit more direction. This is going to be something that will come out based on the calculation. And then you'll have your medium priority. The team should identify appropriate action to improve and prevent this one, or justify actions taken. And then low is the team could identify or improve preventative actions but are not required. At minimum, the statement that no further action is needed must be included in the form. So another thing that's changed is that instead of having the recommended action and then who's doing it and then action taken and then a recalculation of the RPN value, you now have an optimization form. And so you have the preventative action, the detection action, and the responsible person, the team completion date, the status, action taken with pointer to evidence, and then the completion date, and then the new severity, occurrence, and detection. And so that's additional information that needs to be provided that we didn't provide before. Then the seventh step is risk communication, and this is based on the investigation, what's going to be done. Some of the formatting in risk communication is that there's some executive summary, some evaluation of the areas that have been identified that need to be improved, and what action are being taken. It also would communicate the scope of the FMEA and what systems it was working on. It'd be referenced to the scale tablets, tables being used. It would reference the action prioritization table and showing why they were taking action, and was it a high, medium, or low. There any results and conclusions, and what action was taken. And the push is, again, to try and make the FMEA process a living document. So now we're going to turn it over to Anthony to talk a little bit about some of the software solutions we have at Omnex.
So thank you, Mike. So good morning, good afternoon, and good evening. I see a lot of them who are joined from all the international places pretty late in the evening. Thank you for all for being a patron for Omnex and Omnex webinars. I know Mike has given this long presentation, 7 steps of being from a single FMEA to a 7-step implementation process to FMEA. What Omnex has also done is just looked at this challenge that the industry is going to face, and we have defined our tools. Many of you are existing AquaPro customers, so we will have the new AIAG-VDA version also. Here's a short video describing the DFMEA process that Mike was just talking. So you see a 7-step process here. The first step of that is about forming team, where you can define your team. This is a very straightforward interface in terms of just defining the team members. One of the recommended approach was, Mike, you mentioned block diagram being one of the, because of the interfaces. So the software will allow you to, you could create your block diagrams, and you can see them within the context. These interfaces lines could be of different types. Then you complete the block diagram that kind of segues into your P diagram or parameter diagram. You see the block diagram, and there is also linkages between the P diagram to your DFMEA as well. So now what we are doing is having a different way of now creating DFMEA here. A structure analysis to show you the example. What we have is a wheelchair system, and then you have a brake system as one of the subsystem, and all the other subsystems, and you can expand from one level, one structure to the next level, so you can see from a system, subsystem, component, and the levels below. The sliders on the top will allow you to navigate from to different levels, and you can hide or dock them if you don't want it. The next step is the function analysis or the function net. Okay, this will be a slightly different interface from that of what you again worked in AquaPro, or your two-dimensional Excel spreadsheets that you might have been using. So on the left-hand side corner, you look at a block, bill of material structure where you see the structure, and then as you select each of these elements, you could see the functions and the requirements. And with the software, it's a one-click where you can assign a system, a function and a requirement between a system, subsystem, component. You will be able to click and choose what you like. And then at the bottom, you could see the tree build automatically as you place these functions and requirements. It's more of not even a drag and drop, but just one-click touch. Okay. So the arrows depict the flow down and flow up of requirements. Now, for users who are comfortable with the tabular view, you can also switch to tabular view. The next step is the failure analysis, where now I'm switching from a function net to a failure net or a failure analysis. Now, the difference that you will see now is that same tree structure changes from a function requirements to accommodate failures as well. So from a learning curve, you just have one interface where you're able to move from a function net to a failure net, and a GUI that could help you easily understand how the list of functions of a particular system or subsystem or component and their functions, requirements, and failures right here. Okay, so these, the lines that you see on these are defined different levels. The green one is to say it's a failure. There are other capabilities in the software. Due to the time constraint, we're not going to just limiting to just the main workflow here. You could add more failures right here in this software. So it's one place where you are able to create your failure and function net as you move. Okay. I'll fast forward here a little bit to there are different views now available. As I said, you could either have a view of a tree structure or switch to a table view. You can see requirements between. Now, you could also assign requirements and functions between a component all the way directly to the system without really having to go through a subsystem level. Okay, so the next step is the risk analysis. So you could actually have a risk definition of severity, preventive controls, their occurrences, who's the responsible person, what is the possible target date and status. You can see that for both preventive and detections. And the risk optimization is also available, where you have the preventive action that was taken, what was the revised ratings with completion dates and targets. Okay. Anything you would like to add, Mike, at this point?
As you went through the presentation, you can see that there's a lot of added complexity that's gone into doing the FMEA. In the handbook, they say you can do it doing a spreadsheet, but in actuality, you need a interrelational database to connect these different function nets and failure nets, and you don't want to keep creating those over and over again. So that's one of the advantages of going to a software solution. The other thing is you can establish a library of failures and and effects and failure modes, and that speeds up the process when you start developing your FMEA.
Perfect. So the last part of this is that you could also see a two-dimensional view of the DFMEA, which is a tabular view that we saw in all the presentation. Maz, maybe this is a good time you can start the poll.
All right, the polls are closed, so you can move on now.
Before I continue to talk about the PFMEA, I just want to cover a couple of things about the challenge that you're going to have applying this new technique. And like I said, I've been using on and off. I've been working with a similar method for the last 10 years, and sometimes you'll be told that you can just upload your Excel format into the software, but I'll tell you right now, from my experience, it's going to be easier just using your old form as a reference and then just building your structure and doing it from scratch, because the amount of work it takes to clean it up once you're done is more work than just going in and putting it in structure first. So, because what you're doing is you're taking the current form that we're using for an FMEA is a two-dimensional form, and what you're doing in this new failure net and function net is you're putting it into more of a three-dimensional form, and they don't mesh up really well. The other thing is that in the current method that we do FMEAs, each line is considered a single point failure. In this new method, you can establish causal logic that would say for this failure mode to occur, it may take three of these causes occurring simultaneously. So almost similar to a fault tree analysis. So look at this new system as kind of being a mesh between the current FMEA system and fault tree analysis. Got kind of the same features. So now when we look at the PFMEA, you're going to be following the same 7-step structure.
Yeah, Mike, just to interrupt here, I just want to say that just for clarity purposes, that's only for users who are coming from maybe an Excel spreadsheet or something like that.
Right.
So if they're already having, AquaPro users, because I have a lot of AquaPro users, they should be easily able to transition to the AIAG-VDA because it's a database model.
Yeah, thanks, Anthony. That's good clarification. I was talking about if you had
a spreadsheet,
an Excel spreadsheet, not if you were in AquaPro.
Yeah.
So now getting to the PFMEA, it's going to follow the same 6-step process. It's going to have a function net, failure net. It's going to have a structure diagram, all the same features. We still recommend that a flowchart's done because you're trying to draw a relationship between the different operations in your system. As you can see, when we go forward a little bit, you're going to lose that a little bit in the structure diagram. You also it'll be harder to show that relationship between, that we currently use for doing audits and evaluations of PFMEAs, of the flow chart connected to the PFMEA connected to the control plan. So that's not really clear how that's going to be handled. And so you get into this structured format. So you see how this changes from a flow chart. Instead of having step 1 to step 2 to step 3, you're basically saying you have a manufacturing process that has 18 steps. And then within each of those steps, you're going to have band machine material methods. So kind of like the cause and effect diagram type of evaluation. So you won't really see the connection from process step 1 to step 2 to step 3. It's kind of a little bit vaguer, a little bit more difficult to look at. So I can't see completely stepping away from the flow diagram as a method to evaluate the system, and then put it in a structure diagram to further analyze it. So the lowest level in the PFMEA constitutes the man method material and machine. So you have your process flow, and you enter that other information on the form. So you have this structure analysis, which will be different than what we were used to, which would have been operation step and then the process step. So again, it's going to be a little bit, it's going to be a lot different. I see some problems with this method in the plant environment because any added complexity they don't deal with very well when it comes from FMEAs. And so I see a real challenge in applying this at the plant level, and it's going to need probably extra headcount to be supporting this methodology. Same thing at the DFMEA level. The companies that I know that have tried to apply these types of methods have had to add additional headcount where the person was an expert in applying the method and working with the organization so that they understood how to use it. It's a little bit more of a challenge.
Thank you, Mike. So, just as Mike mentioned that there is a 7-step process for PFMEA as well. So pretty much the same. Step 1 is still a 5T. There's a structure, so you can see you document the PFMEA team. Then you would also have a step 2, which is the structure analysis of defining the process and the actual operations associated with each of them. So you could create your operations here, and then you could move on to the 4M. And Mike, is it only limited just to the 4Ms, or is it like a minimum requirement?
It's a minimum. You could expand it out.
Okay, yeah. So that's what you need to look at, is that you're not restricted just to the 4M, but it could be beyond just the 4M element. So software will allow you to create those 4Ms for you. You can then go into the step 3, which is the I'll just wait for the video to in terms of the functional analysis. So you'll see those operations that you created are already listed, and as you go from one operation to the other, and this is what Mike was referring to as a process flow, where it shows you the steps, and then you could also see it as a nice process flow, just like how you have it in our current AquaPro software. So here's the tabular view where you're entering the characteristics information, and as you populate the characteristics information, is associating it to that operation. And you could also add any functions associated to that product. But one element here, if you know, the function analysis both for the DFMEA and the PFMEA, it's a very similar looking interface. The only difference I would think is here you're talking operations and characteristics and the 4Ms, versus in the DFMEA you're really talking about information on your functions and failures between systems of subsystem and component. Again, we'll be able to create all the 7 steps. Let me see if I can fast forward a little bit here, so we have more time for Q&A. So you can see how the lines are automatically drawn between the work elements and also the different functions. And the next one is the failure analysis. You'll be able to define all the failures, and fast forward a little bit. So the failures are added associated to each of those, and you can add the effects. So now you can see a failure and the effects of all in this interface right here. The risk analysis side of it, where you have your severity, prevention, occurrence rating, the target dates, the status of each of those preventive actions, and what are your detective controls, ratings, and the person responsible. This is the optimization step where the revised preventive actions, occurrence ratings, your detective actions, ratings, and completion dates are all included. Okay, this view here is what we also saw in DFMEA and also in PFMEA. So those of you who are not comfortable with using a tree view, you could use a two-dimensional form. Just that instead of one column, as you mentioned, you'll now have 3 columns, and the data is going to be shared automatically between these 2 different views. Okay, so you would have these two-dimensional table view for both PFMEAs and DFMEAs. Here's a quick, the 7th step, where you're having the executive summary, scope, and this is the process flow. As you created those process steps, the software will help you define the process flow, the action priority, and what is your overall risk reduction and results and conclusion. Mike, you want to continue?
Yeah, we're running out of time, so I'm just going to briefly talk about the fact that additionally in the handbook, there's MSR FMEA, and this is basically getting into what you would see in ISO 26262 from a safety point of view, talking about diagnostic coverage. So if I have some type of an electronic circuit that's sensing something, and it's supposed to do some mitigation so that I don't, like accident avoidance, for example. There's electronic systems that are doing accident avoidance. So how good are these systems that are trying to diagnose am I going to have a crash, and then how does it mitigate that? The MSR doesn't just focus on safety, though. It could be a electronic control system that impacts the primary function. So it may be I have some type of a control system that is set up when I key on the vehicle or start up the vehicle. So it's not restricted to safety, but it can be used, and it's basically taking a potential cause due to some type of a sensor or control circuit and looking at the risk that you have based around that. So that's really all we can cover in the manual right now. We can now go to some questions. Okay.
So, Mike, let me scan through some of those questions here for you.
Okay.
A lot of questions. So, you want to read that question out?
How does this differentiate causes from design causes at my level versus the fact that the design failures at the subsystem level? And again, that would be covered in the failure net and the function net. You would have failures that would be associated at your component and design level, and then you may net those to some of the failures at the subsystem level, but the subsystem would also have specific causes that would occur at the subsystem level that wouldn't be associated to you. So that's what I was talking about, is this netting down to the component level is going to be a challenge for those that are like first-tier suppliers down to the second, and second down to third.
The next question is, in this new guideline, have they defined any additional guidance related to bulk materials compared to components like the current edition does?
What I've seen so far in the early drafts of the document, I didn't see anything that was associated to bulk materials. So I don't think they've really dealt with it. I think specifically here we're talking about generic components and systems, not bulk materials. So I would consider the default would be for bulk material to continue to use the 4th edition until something's been released for that.
I think this is a question here on the software side. It's asking, there are existing ARCO users, they're saying, how does their existing FMEAs by production item be integrated or automatically pulled into the new net strategy view? How to toggle between the two? So I think what you're asking is you already have your FMEAs, and then how do you do it? So as part of the AIAG-VDA transition plan, we will help you with the transition for all the ARCO Pro users. We can convert, we'll help you convert your existing design and process libraries of segments into production items, and then you can use that to have your function nets and failure nets. Can you please describe how product and process characters are handled in the new template? Control plan still has as a primary part of the content, but it's not clear how they're going to go into it.
Yeah, that's still, I'm not completely clear on how they're going to handle that. It's going to be rooted into the function nets and requirements. So when you're establishing these function nets, you're establishing what the requirements are at those levels, and then at some point you're identifying potential causes, and then what type of detection is going to be done at those causes. So it will be in the net process. It's just unless you have some software that then connects those detections to the control plan, it's going to be a little bit more difficult to pick those out when you could have done it on the two-dimensional form fairly easy. So it is a little bit more challenging. And if you're doing it longhand, you'll see it, but it's still going to be a little bit more difficult. So I haven't seen a clear definition on how that connection is going to be made.
I think this is more of a software question. Will you suggest rebuilding them, pros and cons of a tabular view versus a visual view? But you can always comment later. The thing what really was asked is, we have a two-dimensional view even for the AIAG-VDA. Would it be a preference to build it that way versus a tree view? My preference is, I think it's just my suggestion would be it's what the user is comfortable. The software does not differentiate whether you have a tabular view or a visual view. The tree view is something what has been very popular in European countries where they are already working with VDA. But I think for the North American customers, I would think, or the rest of the globe, as it's an AIAG 4th edition, tabular view has been the one. That's one of the reasons why at Omnex we actually created that tabular view, where you're still getting all the benefits of having that tree structure and information, but it's a lesser of a learning curve, Mike. But what is your thought?
It's the quicker you start doing the structure, the easier it's going to be. I mean, it's easy. It may seem more straightforward to use the tabular form, but once you get used to this idea of a function net and a failure net, and then the failure net. So what you're doing is functions for the three levels, the system, subsystem, and component, and then you're attaching those functions as a function net. So that's what's happening with the structure diagram. And then once you have your function net at each of those levels, at a system, subsystem, and component level, you're listing out what the potential failures could be, and then you establish that failure net or that failure relationship. So, and like I said, the further you are down the food chain, the more you're going to be relying on some of the structure information to be coming from your either OEM or first-tier supplier.
Okay. So there's a question on, could we show us how a PFMEA works? We covered that, but if you're interested, to look at a little bit more in depth, we can set up another presentation or a software presentation on the PFMEA side of it. The question is, does the PFMEA form have the same extent of changes as the DFMEA does? So, go ahead, Mike.
You mean from, if we're looking at it from the standard fourth edition to the new, it's going to be exactly the same form that's used for the function net, failure net structure that's for the DFMEA is going to be exactly the same for a PFMEA.
Yeah. So the same steps as DFMEA, the AIAG-VDA edition, DFMEA and PFMEA follows the same 7-step approach.
Yeah. Yeah. So it's not going to be anything different. The problem that you have, like I said, is that when your first level of the structure is going to be, this is what my operation is, and my whole operation could be, assembling something. And then you're going to have op 10, op 20, op 30, op 40. They would be the next level structure. And then within op 10, then that's when you do the 4 M's. And see, the problem I have with that structuring is it doesn't tell me that at op 20 I might have 5 machines, or I might have one machine at op 30 and it's got 10 stations. It doesn't handle that with the structure diagram. And so that's what I meant, that you really need to still do a flow diagram to be able to understand the complexity of the issues at each operation that you'll start to lose in the structure diagram.
Great. So the question is, there was a question, okay, we are planning to buy the new AquaPro. Will it support the existing old and the new FMEAs? Yes, we will support both the AIAG 4th edition and also the AIAG-VDA editions. Do we still continue to have some of the segment approach that are unique to AquaPro? Yes, you will have both the design and process segments for AquaPro, part of AquaPro. It will continue to be in AquaPro for enabling design and process reuse. So this is a question: can this PFMEA structure generate an aligned process control plan? Yes, that's a very good question. So when you complete a PFMEA, you would still, just like how you have in your existing AquaPro, about 70% of your control plans will be auto-populated. So creating a PFMEA would enable you to create auto-populate the control plan. It's a question in a function diagram. Would it be possible to link between different subsystems for the interfaces with energy number?
I don't know what the energy number
I don't know what an energy number, but if you're asking, can we create can we draw interfaces between system subsystems? Yes, you can. And the block diagrams really is where you would actually draw interfaces between the subsystems. I would think, Mike, what is your thought?
Yeah, the problem that you have is that the structure diagram doesn't really handle the interfaces. So what happens is your interfaces become potential causes of failure. And that's a reason that I said that you need to still do the boundary diagram, you still need to do the flow diagram, because you won't see those connections between systems.
Right.
Now, you can do some linking, but based on the software, it may have limitations on what you can link from one subsystem to the next. So, what I've seen is when this system's been used, interfaces become potential causes or are part of the functionality of the design.
Yeah. So one thing, just to add clarity to that question. What we did not show in the presentation today was we did not talk about interface function metrics, which we have it in AquaPro.
Right.
So when you build, so the short answer is you can use the boundary diagrams to link interfaces, and you could actually label these interfaces at their different energy segments. And as you build these, an IFM or an interface function metrics is also generated where you can rank them and rate them in terms of the risks. When does it become a new standard? So there's a question: when does the new standard become effective, and do we need to retro integrate programs already in production?
Normally, you don't. Normally, if this follows all of the procedures of ISO and our IATF is there will be a time period of transition. There won't be a requirement to move to this format if it's an old design. But I'll tell you right now, you're eventually going to have to do that when you start to upgrade your design. You're going to have to start moving them towards this new format. So initially, I would say that you're going to probably have at least a year grace period, depending on who your customer is. And then after that, you're supposed to be applying the new system. So anything that's new, you'd have to apply it to. And again, if you were trying to, if you're got an assembly operation and you've got different components, sooner or later you're going to have to integrate them all to the new system so that you can have them communicate with each other. So, so it's for a while you're going to be in transition.
Yeah. Okay. So we have just time for one last question, which is there was a question: how is it going to help prepare DVPNR? So when you finish your DFMEA, I think the question is related to more about AquaPro asking, if I finish my DFMEA, which existing AquaPro allows you to create the DVPNRs and test plan, would it just continue to have it? The answer is yes, you would. Even though you see three-dimensional, a single function being split now in 3 different columns or failures being split as 3, these automatically get apportioned into those respective test plans and or DVPNR, and you will still be able to do your DVPNR.
Yeah, because it's still going to be buried into the structure diagram to where you can get to that, where the detection. What type of detection are you doing? And in the DFMEA, that's what type of validation tests are going to be done.
Okay. So with that, I think your concluding slide in terms of what you want to offer. So we'll offer trainings, of course, workshops. We'll be helping customers with transition programs and also consulting opportunities and mentoring and coaching as well. Right?
Yeah, that's right.
And of course, with one of the advantage that they can take when you're doing these trainings and implementation is use a software-based approach. So as you are going through these trainings and workshops, you can transition into the software and have a more integrated, holistic implementation of AIAG-VDA.
Yeah.
All right.
That's true.
That said, thank you all.
Thank you very much for coming.
And look forward to meet you in the next webinars to come. Thank you, everyone. Have a wonderful weekend. Bye now.
Bye.